Doug started birding in Maryland in 1966 with a guy named Chandler Robbins, and I expect a lot of you know who Chandler Robbins was. And
Yeah.
Doug will, and some of you will also recognize this book. This is the original version of Chandler Robbins' field guide that competed with the Peterson field guide. By the way, you can't see it, but the cost of this is $2.95. There's a later version here, which was $10.95. Anyway, the appearance of that field guide divided some of the ornithology types back there in other parts of the country. Doug arrived in Montana in 1975, and he discovered that Missoula had no Audubon chapter. So he started one. Valleys Audubon, which is still vibrant today. That's a good group down there. After earning degrees in wildlife biology and electronic engineering, he worked alternately as a biologist and an engineer. That must have been a challenge. His custom tracking devices have been used on dozens of critical wildlife species around the world. Today, he has a day job with Microsoft's Surface Pro devices and weekends with his new Montana nonprofit Field Data Technologies, which has obtained $825,000 of Department of Agriculture grants to design new types of wildlife instrumentation. And that's something we can certainly use. Title of his presentation tonight is Instrumented Bird Nest Boxes and Wildlife Tracking Technologies. So I'll turn the program over to you, Doug.
Great, thank you much, Dave and Gail, and a whole bunch for giving me a chance to talk. Yeah, this is exciting, talking to an Audubon chapter again. I used to talk to Audubon chapters and do field trips all the time, but it's been 45 years since I'm finally getting back to it, but better late than never. I'll be talking about these devices that can go into bird feeders and bird houses to log all of the activity nesting, but let me try to share the screen so I can get into it. And let's see, looks like I want that one. And
there, looks good.
This looks good.
Presentation mode, how's that looking?
Looks good.
Good. This talk is going to be, might be a little bumpy because it's a mashup of several related topics. I'm going to try to cover basic tracking locational devices that have been used on wildlife and the history of those developments. And I'm going to jump to one particular project in the middle of Papua New Guinea that's kind of indicative of cutting edge tracking projects. And then I want to get into my new passion, which is to get beyond the tiny number of scientists who can score permits for tracking studies. I want to get equally robust scientific instruments into the hands of Audubon's and amateur scientists and undergrad students to do some serious automated instrumented wildlife research, because I want to bring a much bigger group of people into doing genuine science. As Dave mentioned, I have toggled between engineering and field biology. It's a little strange because they are different cultures. In fact, both engineers and biologists deal with antennas. But when you go to Webster's dictionary, you will see they have to have one version for engineers. The plural for engineers is antennas. The plural for biologists is antennae. And we have different perceptions of what things should look like. As an engineer, we like to design things that are aerodynamic and sleek. Like this sage grouse tag, I designed it long and narrow with the antenna trailing out behind it. Biologists have a different take on things. They spell plural of antenna differently. And when a biologist thinks about an antenna, it's not trailing out behind, it's sticking out in front. So when I design these things with the antenna to go backwards, if you just hop on to Google Images and do a search for satellite transmitters and wildlife, you'll see 8 out of 10, the biologists attach them the other way. Fortunately, they still work when they're backwards, but just kind of curious, the two different perceptions of antennas. And if you were to ask an engineer to design something that can fly, they probably would not design something like this. But condors are very good flyers. And I do like designing custom tags for big, strong flyers, because these guys can carry big batteries, which mean I can put all kinds of technical goodies on the tags. That's one of my GPS tags on its right wing there, and a pentagonal marker on the other wing. This was one of the releases at the Grand Canyon a couple of years ago. There's a general rule that our transmitters should not weigh more than 3% of the body weight of the animal. So a condor can carry a pretty big tag. You might think this big great gray could carry a big tag too, but because they are big, but it's all feathers and fluff. These things only weigh 1,000 grams. It's about 2 pounds. So that means our transmitters have to be down around 25, 30 grams at the most, but we managed to do some GPS on them. Owls are tough because they're not out during the day, so you can't put a solar recharge. You have to do it all with batteries. This particular bird was hanging out on Harrison Ford's ranch in Jackson, Wyoming. So I got to know Harrison Ford's ranch in much detail, looking at Google Earth at all this little custom golf course and all the cool stuff he's got going on there. Attaching can be challenging. There's lots of creative ways to attach tracking devices, many of which you never see on Discovery Channel. I spent 7 years making saltwater marine tags, and those are really tough because saltwater destroys electronics really quick. The slightest little crack, salt water will seep in and kill it. You get a sperm whale that can dive 2,000 meters. It can crush batteries, but it doesn't hurt the animal. And it can crack your tag and let salt water in. And think about a penguin. A penguin might be sitting on an iceberg in 50 below 0 Fahrenheit, and then dive into seawater that's about 30 degrees Fahrenheit. That's an 80-degree temperature shock instantly. So that keeps my mechie engineers on top of things. Dave might recognize what I'm going to show now. These are two of the professors from back in the day, John and Frank Craighead. They were huge pioneers in the tracking biz. When they started, the only kind of tracking device was a very simple RF beacon. And the way you track an animal was to follow it on foot with a handheld antenna. It's still the way most tracking is done now because VHF beacons are very inexpensive and simple to make. You can make them really tiny. But back here in the day, the tech was sketchy. The drugs to immobilize the animals were sketchy, and these two guys stepped up and did it anyway and broke new ground. Their work dramatically changed the perception of grizzly bears. It changed how they were managed in the park. It helped get rid of the garbage dumps. It even triggered a political storm that triggered some congressional hearings that came down on the Park Service because the Park Service was not very science oriented at the time. Congress forced some structural changes, so Park Service now is very much more science-based. And I think we could take some lessons from what Congress did back there in the 70s. to infuse more science into the agencies. So anyway, this is what the game was like back then when didn't quite have things figured out.
Oh, yes, I remember that one. Oh, boy.
Phew. Yeah, well, heart rate goes up just watching that one. Um, well, that was then. This is now. Got the drugs figured out. Got the tech figured out. You might recognize a couple of Tim Hamlin's texts there. I don't know where they took this one. Might be downtown Whitefish or Big Fork or something. And the tech has come a long way. When John and Frank were doing it, the VHF and following it on foot was the only way to track an animal. That had been done on wildlife since the 40s, leveraging radio technology from World War II. But the problem with grizzlies is they'll just get an itch to get up in the middle of the night and walk 20 miles and cross a mountain range where you cannot pick up your signal anymore. So then you got to spend your precious grant money hiring an airplane or a helicopter to try to figure out where your bear went. Well, John and Frank had a friend they knew in the Navy in the war. And in the 50s and 60s, the Navy started putting satellite beacons on ocean buoys. So John and Frank had their engineer friend chop the satellite beacon off of a Navy ocean buoy, and they hung it around the neck of a grizzly bear and invented the world of satellite tracking. This way the bear could go over a mountain range and you didn't have to hire an airplane to go find it. That project largely inspired NASA to create and launch the Argos satellite system. Satellites dedicated to tracking wildlife and other environmental stuff. So again, they did some groundbreaking work. So the technology that goes into tags now, oh my gosh, if I had some biologists ready to buy a tag, I'd have to spend 6 hours talking about this slide. I'll just real quickly, it's grown a lot more than just VHF beacons. We've got Argos satellites, Iridium satellites, songbirds. In the last few years, we've done fabulous work with tiny little geolocators. All it is a very accurate clock and a light sensor to get the time of sunset and sunrise. And using the exact same math that the ancient mariners used in the 1500s, if you have an exact time of sunrise and sunset, you can tell where you are on the planet. And in the fall and spring, you can get it down to plus or minus 10 miles. A little bit trickier at the equator and the poles, but a great way to put a very tiny, very simple tag on a songbird and figure out where they spend the winter. GPS, of course, you're all familiar with. Problem with GPS is the tag can figure out the location, but then how do you get that data off of the tag? Well, you can store it on board if you're sure you can recapture the animal, or you can transmit it back off of the tag up to a satellite or a wireless connection, Bluetooth. There's a new thing called LoRaWAN I'll talk about in a minute. Using cell towers is really big now, that except in Montana because cell coverage sucks. But the rest of the world is pretty good with cell coverage. And then once you got your basic platform and communications, then you can tack on all kinds of sensors depending on how much battery you're willing to put on an animal. The way these discussions typically go with a biologist is they come in thinking, I want the smallest tag I can put because I don't want to affect the animal's behavior. So, okay, small battery, it might last a few months and you only get a couple of locations a day. Oh, we want more than that. Well, okay, that's a bigger battery and then we can put temperature and humidity on. Oh, we want more locations. Okay, a little bit bigger battery, and now we got 10 locations or 50 locations a day. And pretty quickly, you wind up back at the biggest tag that the animal can carry. And the thinking is, if you're going to take a risk to capture an animal with a risk to the animal and the capture crew and everything else, you might as well get as much data as you possibly can. So we typically do go all the way up to the 3% body weight rule. As an engineer on the project, I have it really good because I can choose which projects I can go to in the field, because all I have to do is say, oh, gee, this is a sketchy new prototype and I don't know if it's going to work right and I better be there to put it on myself. So that way I can score some first class flights, this particular one to the middle of Papua New Guinea, to capture some tree kangaroos. Although when I saw the helicopter and that antenna, I was a little worried that this helicopter was designed by a biologist instead of an engineer. But I got on there anyway and managed to get up and over a 10,000 foot ridge and up this mountaintop, as way up above even where the villagers ever go. But a bunch of the villagers are hired to help support the research and bring food. They bring all their kids. So we're all up there, 6 degrees off the equator, but almost snowing. It was 35, 40 degrees F and raining. So pretty tough stuff. We were looking for these things. This is a tree kangaroo. It's a little marsupial, very much like a kangaroo, but it lives up in the trees in the cloud forest. This is an extremely endangered one. There's 13 different species of tree kangaroos. This is the Matchies, which is very endangered, had never been GPS tracked before. So I designed some custom tags. The local hunters who hunt these things for meat, they're very good at capturing them live, don't even have to use drugs. Capturing them probably the same way they've been catching tree kangaroos for 40,000 years. They spread out through the cloud forest looking for that yellow tail hanging from the treetop. When one guy sees it, they start hooping and hollering. All the hunters come around and make a big circle around the base of the tree. One lucky guy climbs up in the tree until the tree kangaroo jumps out off the tree, and when he lands on the ground, the hunters all grab it. So they're able to grab it, put it in the bag, and bring it back to camp. Cute little animals. My goal is to have Disney make a feature film with this as a lead character, because they're just endlessly cute and fascinating. These projects provide some year-round employment for some of the locals. They don't normally have any way to earn cash at all. This is 100 miles from the nearest road. There's no logging roads or mining here yet. So supporting the research camps is good, and got them trained up to follow them and get data off the computers, hire others to carry gear. The men won't carry our gear. It's the women and the kids who carry it. The men just carry their bush knives in case they find a tree in the way. They can cut but the women do the work. That pack, they're weighed in at 50 kilograms. It's an 85-pound pack. She's carrying it barefoot. I thought I was in good shape. I could barely keep up with these people. And I didn't have to carry anything. There are shoulder straps and hip straps on these packs, but they prefer to carry it on their head. There's also a very way cool arrangement. There are some fabulous coffee plants that were brought there by missionaries in the 1950s, except there's no way to get the coffee beans out except to fly them. And if you fly beans out, it's not commercially viable. So they had no way to sell their coffee beans. So the Tree Kangaroo Project arranged a deal with a few high-end coffee shops in Seattle, agreed to pay 3 times market price for the raw beans, sold as Tree Kangaroo Conservation Coffee. That 3x price made it viable to fly the coffee beans out of these remote locations. And the exchange is the locals agree not to hunt tree kangaroos on the preserve for the Natchez tree kangaroos. So really way cool deal that all flows from these research projects. Here's the very first GPS tracks of some tree kangaroos, very territorial. The green and the blue are males. They roam over larger areas. You can see the red and yellow. That is a mother with an 18-month-old joey. They stay together in the same territory for about 18 months, and then the mom will chase that joey off and to mate again. Also put an altimeter that was sensitive to 10 centimeters up and down, so we could tell where they're spending time in the trees. Once per second motion, so we could tell when they're active during the day. The biologist's been studying them there for 30 years. He thought they were just active at sunset and sunrise, but we see there's 4 peaks of activity. They're active in the middle of the night and at noon. The theory is that their digestive systems are pretty simple. They're eating leaves, which are not high quality. They probably need to eat 4 times a day to maintain healthy metabolism. So, okay, so much for the old-fashioned kind of tech. I want to talk about how I'm transitioning away from invasive captured attached things. I want to move to similar technology that you can put in your backyard in a birdhouse or a bird feeder. I had 75 prototypes out in the Seattle suburbs last year. This thing logs once per minute barometer, humidity, temperature, ambient light, once per second motion, takes pictures on a schedule. So you get this complete log of feeding rates and how it relates to weather. I moved them from Seattle. I got 45 of them back. And these are now installed along the Hungry Horse Reservoir Road. I'll be adding the instruments here maybe next month or maybe April. I had them all painted green in the Seattle suburbs. We got about 30% occupancy. I thought I'd try other colors. I've got green, brown, and birch pattern. If you can find me on Facebook, there's a Facebook pool as to whether you get more using green, brown, or birch. So feel free to place your bets. Winner gets a free instrumented nest box. So I've got one version that fits these PCV pipe nests in the same device in a long skinny thing, so you can put it in and out of a traditional wooden bird box. In fact, the one in the lower right, all you have to do is put a hollow tube, that cheap plastic part, in lots of different birdhouses, and then you can move the instrument around to different birdhouses depending on which one's active. So a really fun way to gather pictures and data on nest biology. Here's one way to chart the data. This shows the number of trips per day in and out of a chickadee nest box. And you can see there in April, something is poking its head in a couple of times, possibly exploring for a nest site. had a high pressure, bunch of sunshine in May, seems to have triggered nest building, a couple hundred trips per day, moving material in and out of the nest. Eggs hatch, there's some more activity. And then feeding rates range from 300 up to 600 or so trips per day, bringing food in for the young. Had some storms come through that knocked feeding down for a couple of days, and then fledging. So in one picture, you get a snapshot of feeding rates and how it relates to fledging and all. The grants we've got coming in now, we're doing some new tricks with it. There's a new wireless game called LoRaWAN, short for long range wireless area network. Same low power as the Wi-Fi in your house. But as you know, the Wi-Fi in your house can barely get around a medium-sized house, maybe just barely into your backyard. This new game, equally low power, but it can jump 1 or 2 miles. So it's fabulous for instrumenting a bunch of devices across a study area. So we'll be doing this for reptiles in California, for red macaws in Peru. I haven't added the wireless to the Hungry Horse Reservoir, but we could do it there too eventually when we get some time. They actually just a few months ago, they took one of these wireless transmitters up in a hot air balloon over Amsterdam, and they hit a mountaintop in Czechoslovakia, is 500 miles away. So this can go really long distance. But there's a huge trade-off. You can only send a few bytes, no more than 100 bytes per minute, not bytes per second, bytes per minute. So you cannot do video. Even sending a medium res picture will take 20 days. So I cooked up a new game where if we use a smart camera in the field that teases out moving objects, does some other image processing tricks, and boils the moving object into just an outline, we can get the image size down to 800 bytes. It'll only take a few minutes to transmit it over LoRaWAN. And for a lot of wildlife projects, like here in Bellingham, we're trying to find these Asian giant hornets that are showing up. An outline is plenty good enough to tell you whether you've got a honeybee or a giant hornet or a moth or a stick or a leaf. So we have high hopes for this new trick for doing image data across long range, low power radio. Well, I will finish my talking there. We can't say anything without politics these days, so I will end it on a political note. Just asking everybody to participate in science, count every bird, and keep records, and keep the growing body of nature information moving forward. So I'm hoping we got, do we have a few minutes for questions?
I hope so.
Yes, I think people have to unmute, but go ahead and ask questions.
I was wondering if you have any ways for tagging politicians to find out where their influences are coming from.
You know, we used to get phone calls from parents of teenagers.
Yeah.
There's a lot of applications.
Yeah.
The company that really dominates wildlife tracking, Telonix down in Arizona, they get most of their money from Pentagon contracts doing spooky work. But it's a great way to provide funding and engineering expertise that can be then translated into wildlife stuff. We,
I have
got
some, practical information already about my mountain chickadees that are nesting in the nest box in my front yard. So I suspect I better be looking for them, checking out the place in April, and in mid-May they're going to be getting busy. So
yeah, the whole nest exploration and choosing a nest site, that there are no good tools for that.
yeah, it's very cool.
It's biologically, that's a huge question.
Yeah.
And I should mention, I've also stumbled on a way to make a almost no spill feeder, taking one of those PVC nest boxes, putting a bunch of holes in the top, instead of just one, fill it with sunflower seeds, and suddenly you have a feeder that has almost no spill because the chickadees have to go inside, grab one seed and fly back out. And with only one bird at a time, it's much easier for devices to tease out how many birds are feeding, and it's specific to chickadees and nuthatches for the most part. So we're getting some really clean data on feeders. In general, feeder data, I know you've probably seen the Kickstarter for the new feeder device, but data from a feeder is kind of tricky because what are you really measuring? You mostly measuring how big of a pile of sunflower seeds you can put out and whether your neighbors also have feeders. Whereas a nest box, I believe the scientific gold is in the nest box. Because when you're logging feeding rates and logging how many chicks get fledged successfully, that's a fabulous measure of local habitat quality. If the parents can crank out healthy babies, you got some good stuff.
Yeah, yeah. It's the bottom line.
Doug, I'm not sure if you mentioned this or not, but do you, your sensors and stuff, is there a way that one could find them, or are you still just testing them out, or how does that all work?
Okay. Here's my chance for a plug. Beginning next week, I have one team at Texas A&M and Hawaii, University of California. I want to start a parallel team down in Missoula, and to not focus so much on these little hacker small time projects, but rather focus on commercializing it in a serious way. And National Science Foundation has a program that puts you on a track to seriously measure the market potential, and then apply for the big SBIR grants for commercializing this stuff. I have a team of 3. I'm open to adding additional people. You don't have to have necessarily tech skills, but it starts out next week with 3 sessions where we systematically interview customers. And I've only talked birds here, but actually the big market potential here is with precision agriculture and insects, pollinators, and invasive insects. So we're going to be grilling that market pretty hard to see what the potential is. Salmon streams, there's no affordable instruments for logging salmon going up the stream. There's over 5,000 inland oil spills in the United States every year. Most of them are small, but those mandate some monitoring of cold-blooded animals. Since my device detects an animal with images, it's very different from a trail cam. A trail cam detects a warm-blooded animal moving against a cold background. It's triggered by an infrared sensor. But by finding moving objects, and my device has one of those too, but I can also find moving objects just by taking lots of low-power pictures. So now it works on reptiles and salamanders and insects and fish that trail cams do not work on. So we're seeing a lot of potential in a bunch of different market segments, and we begin systematically analyzing those segments and making a business plan to make this available. in a bigger way. Because for me, it's getting this out to citizens so that citizens in public school classrooms and stuff can do real science.
So I can't get one is what you're saying right now.
Yeah, a very long, polite way of saying no. I've got some. I've got a few extra ones for this. Well, look, these 45 I put out at Hungry Horse, that was supposed to be a citizen science project funded by the Forest Service for you guys. But the Forest Service has a $30,000 grant for these little citizen science projects. It yanked it because of COVID. So that project is not funded this year.
Oh, we can't hear.
But, Mark, you probably know Mark Ruby and Amy Jacobs over there at the Big Forest Ranger Station. Yeah, they're in on it. Pretty much a shoe in for that grant when that grant program starts back up, and then we'll plug into you guys in a bigger way and get some into backyards.
Hey, Doug, there's a couple questions in the chat boxes.
Oh, okay. Let me pull up the chat box. Oh, let me actually pull out of here. Let's see what I need to do.
There's first question is, have predators eaten the transmitters? If so, do the transmitters still work?
When I was doing marine animals, we'd often tag tuna, a lot of commercial interest in tuna. And the device also had a ambient light sensor and temperature and stuff. And you would see the sunrise and sunset going on normally, temperature about seawater temperature. Then all of a sudden, the ambient light would go black for 3 days. Temperature would go stable. And then it would suddenly come back on again. What that was a shark eating the tuna. Passing through the digestive system of the shark and out the other end, and then we're seeing daylight again.
That's
So
great.
yes, I did a presentation with a bunch of tags to one of the executive vice presidents at Microsoft, who was curious about all the tech that goes into these things. And I described the penguins jumping off the icebergs and, the sharks eating them, and claws and beaks and teeth and water pressure. And he had a few of them in his hand, and he sat back, put his feet up on the table. And he said, this stuff is hard to do. I went, yeah. A user device like he makes, Surface laptops, if it locks up, the user can cycle the power and push the reset button or plug it in to charge it up. When you put one of these on an animal, they don't know to reset it when it doesn't work anymore. It's got to work first time. And when some poor kid's doctoral thesis depends on getting data from these things, that's pressure. So yeah, this stuff's hard to do, but it also makes it very challenging.
And I have a question for you. Can you design, or have you ever designed a mini camera? This would be for maybe a nest box that's close to home that you could actually plug into your house, or batteries that you could replace. But can you get pictures of what the chickadees eat?
That's the goal. That's where we're heading with this thing.
That's the thought. Okay.
The ideal build out of the camera is a close-up one right at the entrance of the birdhouse, so that when the parent comes into an entrance, it snaps a quick picture and you suddenly got a record of all the food items being brought in. Biologically, that's gold. Yeah. Not quite there yet, but it's absolutely the direction we want to go.
Well, let me know. I want one of those.
We do have the camera. I should, there are a bunch of startups, a lot of people doing birdhouse cams. And most of them are going after the consumer market that just wants a real-time feed of continuous wireless video. I am much more interested in a serious science instrument than full-time video.
Mhm.
So I'm going down a different tack where it's only going to take very occasional low power pictures and gather a lot of sensor data and build a real scientific record of nest boxes rather than just flashy video for most people. I think there's room for both kinds of devices. But I really, again, I'm really passionate about showing everyone that everyone can do real science in their backyard.
Doug, one of the things that is really missing in the whole world of information about the interrelationship between native plants and native insects and peak insect caterpillarization, or whatever you want to call it, and when birds are nesting and when they're feeding chicks is very much timed to the native insects eating the native plants, and there's very little specific information in my research about doing this, because I want to do a movie about it this spring. But there's not that much known about what exactly is the trigger thing that keeps these critters from really tuned. And then also with the seasons changing because of climate change, how is that affecting the nesting the sequence of birds? And so there's a lot of questions out there that could be very easily answered with a whole lot of citizens looking at data.
Yeah, that was the track I was on, is trying to tie it to the insects, the timing and where those insects are living, and which species are most important and that type of thing. Very cool.
You need to get Elon Musk's ear to design a smaller battery.
Yeah.
Yes, very much so.
There must be some other questions out there.
I'll tell a real quick anecdote on the insects and sunflower seed.
Yeah, sure.
I had the device on both my sunflower seed feeder and the nesting boxes at the same time in Seattle last year. Chickadees were hitting the sunflower seeds a few hundred times a day. Within a couple days of when the chicks hatched, the sunflower seed use dropped to almost zero.
Yeah.
And I happened to I worked out on my bike every day, and it was also those days when I suddenly started hitting flying insects on my bike.
Yeah.
So I think it very much was timed exactly at the moment to switch from seeds to bugs.
Yeah. Yeah. High protein.
Yep.
Some other questions from folks? That was really interesting. I like
Very
that.
interesting. Very cool.
Yep.